Hey class, I just wanted to do a few of these examples for you just in case you're not quite sure how to get started. The very first thing that I want to notice is what I have in this table. So what information do I have? In this case, what I have is the number of protons and the number of electrons. So what I can do with that is I need to remember that the protons have a charge of +1 and the electrons have a charge of -1. So what that means is I've got 26 protons, that's a +26. I have 24 electrons, that's -24. If I combine those charges together, I'll come up with the overall charge of the ion. So 26 is our positive number, 24 is our negative number. 26 minus 24 gives us 2. And we want to be specific with whether it's positive or negative, so that is 2 positive. Since I have more protons, it's a positive charge. All right, our ion symbol, and there are different ways that you can could do this. If you want to just write it out, that's okay. You can use the instructions for drawing with the scribble tool, or we can just write FE, and then control period sometimes works. Control period will make the exponent or the superscript, and then I could put 2 plus. However you do it, you need to have a superscript with the charge for each of the ion symbols. That's what we're trying to put up. Okay. Now, if that doesn't work for you, another way you can do this is by clicking Insert Equation. And for some students, it doesn't. The control period doesn't work, but this I think always works. You hit Tools. I'm sorry, not Tools. Insert Equation. And now that I'm in the equation, I go over to the fourth icon, which is Math Operations. And there's a superscript right here. You type your symbol, which is FE. Because FE has a atomic number of 26. That's how I know that. Atomic number is 26. The number of protons is 26. And then I'm going to push the over button. That makes the exponent show up. And then I put 2 plus. So FE 2 plus. The ion name. So this is where you would want to look at our notes, and you'd see the place where it tells you if this is one that needs a Roman numeral or not. This is one of those that needs a Roman numeral. So I need to put a Roman numeral for the charge. Our ion name is iron, and then I'm going to put the Roman numeral for 2, which is II. You could put that in parentheses if you'd like, or you don't have to. Either way. Cation or anion, that's just, is it a positive or a negative charge? Since it's positive, that's a cation. Okay, let's do a couple more, and we'll pick up the pace with these. All right, 52, I know 52 is the number of protons. I don't know the number of electrons, but I know the charge. I see that the charge is -2. Now we could work this out with algebra if we wanted to. You could say 52 plus x, or 52 minus x, because remember this is a negative charge. 52 minus x equals -2. And you could solve for it and you'd get the right answer. That's fine. If you want an algebra way of doing it, that works. 52 minus x equals -2. Or we can kind of think about it logically. The -2 charge means that I have more electrons. Electrons are negative. So the -2 charge means I have more electrons, and the 2 means that I have 2 more electrons than protons. I've got 52 protons. If I have 2 more electrons, that would be 54. Or you could solve it with algebra. Either way, it's the same thing. All right, so if I find this on the periodic table, I find element number 52. That is tellurium, Te. And again, you either do control period or you can do the equation, insert equation method that we just showed you. And then you need to put your charge, 2 minus. All right, now our ion name, remember this is a negative ion, so our negative ions are named differently. Negative ions are anions, and they have a different naming method. If it's a monatomic ion, just one element, and it's a negative ion, then it's going to end in "ide." So this is tellurium. I need to drop the last syllable or so, drop the ending of the name, and change it to "ide." So instead of tellurium, I'm going to put tellur. Instead of that IUM, I'm going to put IDE, telluride. All right, the next one, I've got a -1 charge, and I have 36 electrons. I have more electrons, that's why this is negative. I have 1 more electron, so that's why it's -1. 36 electrons, I've got to have 1 fewer proton, 35. Find 35 on the periodic table, that is bromine, Br. And I need to put my charge, which is -1. You can either put a -1, or 1 minus. Any of those would be acceptable ways of showing that it has a -1 charge. Again, it's a monatomic negative ion. This is an anion. So we're going to put brom instead of bromine. Since it's a negative ion, we change it to "ide." Just remember that anion, you change the ending to "ide" unless it's a polyatomic ion. And in this table, you're not going to see any polyatomic ions. So negative ions are going to end in "ide." The positive ions is just the element name. It's the metal's name, but you have to check and see if it needs a Roman numeral. If it is not, in group 1, group 2, or silver, zinc, or aluminum, if it's any other metal, it needs a Roman numeral. Okay, let's do a couple of questions from the second section. Okay, O2 minus. Again, we need to find the number of protons and electrons. The number of protons is just the atomic number. So if I find oxygen, its atomic number is 8. So I have 8 protons. The number of electrons, if it's a -2 charge, that tells me I have 2 more electrons. It's 2 minus. So I have 2 extra electrons. Remember, electrons are negative. So 8 and 2 more than 8 would be 10. You need to have 2 more negatives than positives to give me a -2 charge. Okay, our ion name. Well, this is a negative ion. Oxygen, we need to change the ending to "ide." Oxide is the ion's name. The electron configuration for the ion would be 1s2, and if control period works, that's probably the easiest. 2s2, p4. The Lewis dot structure for it. No, hold on. That would be the electron configuration for the atom. We need to do this for the ion. So how many electrons would I need to get us all the way up to a full valence shell, to get us up to 8? Right now I have 6 valence electrons in the second energy level. I have 2 plus 4, that's 6. To get to the full valence shell, I need to have 2 more. So I'm going to add 2 electrons to the p sublevel, so 2p6. And my Lewis dot structure is going to be oxygen with 8 electrons around it and a -2 charge. Now let's go ahead and use our scribble to do that. Go to Insert, Drawing, New, click on the line and the scribble tool. Going to start with oxygen, that's O. And I want 8 dots around it. 1, 2, 3, 4, 5, 6, 7, 8, drop brackets, and because it has a -2 charge, I'm going to put 2 minus on the outside, hit save and close, and it saves it for me right there. Okay, let's do a positive one, and then we'll move on to the last section of the practice. Okay, Mg2 plus. Mg has 12 protons, atomic number of 12. It's got a +2 charge. That means I have 2 more protons than electrons, so 2 fewer electrons would be 10. It's just a metal. It's a positive ion, and it's one that's in group 2, so I don't need a Roman numeral for it. So the name of it is just magnesium. It's the magnesium ion. The electron configuration for magnesium would be 1s2, 2s2, 6, 3s2. That's if it was the magnesium atom, but remember, we're looking at the ion. That is, after it's either gained or lost electrons to get to a full octet, and it's got a certain charge. Well, I lost 2 electrons. So instead of having 12 electrons, I have 10 electrons. That's another way of looking at this, and I should have mentioned that in the last one. The number of electrons is what your electron configuration is based on. So if I have 10 electrons, we could look at element number 10 even if we wanted to, which is neon, in order to find out what the electron configuration is. Or we could say this is the electron configuration for magnesium, and it's 2, 4, 10, 12 electrons. I want to lose the 2 that are in the highest energy level to get me down to 10 electrons. And that's what the electron configuration would look like. It's the same electron configuration as the oxide ion, actually. Now let's draw the Lewis dot structure. These are a little bit different. You might not even have to draw them. If it's a positive ion, you don't have to use the drawing tool if you'd rather not. You can just use the brackets, because in order to show that it lost 2 electrons, we're just going to put Mg with no dots, and then control period, we're going to put +2. All right, and here's the last section on the worksheet. What we want to do is the electron dot for the formation of an ionic compound. So we have lithium and chlorine. If they were combined together to make an ionic compound, what would that look like? How would that happen? Let's insert a picture. Insert drawing, new. All right, so to start with, you got to find lithium. It's in group 1, so that means Li has 1 dot. Sorry, I forgot. We need to click on our scribble tool. Lithium has 1 valence electron, so 1 dot. The next thing that we notice is chlorine. Chlorine has 7 dots. So I would draw another thing right here, Cl with 7 dots. 1 here. I have 2, 3, 4, 5, 6, 7. Okay. And what happens is, because lithium only has 1 valence electron, that's really easy to get rid of. And chlorine has 7, so it'd be easier for it to gain an extra electron to become an ion. Lithium's going to give 1 electron to chlorine. And then we draw an arrow to show on the other side what's happened. Well, I've got lithium with a +1 charge. And I've got chlorine with 8 dots and a -1 charge. And you can put brackets around the ions if you want to on the right side, but I'm not going to require that. Okay, and then our formula, so if we move over to the next thing, the formula describes how many ions there are. So there's one lithium ion, and there's one chlorine ion, or chloride ion, so we put Cl. All right, calcium and bromine is a little different, so let's do one of those. Going to insert a drawing, new, scribble. Okay, calcium and bromine. So calcium is Ca with 2 dots, and bromine, Br, and it has 7 dots. If you were to find it on the periodic table, it's in group 7A. Calcium wants to get rid of its electrons, so it'll move 1 valence electron right there. But it still has another one that it wants to give. So another bromine is going to show up to take that extra valence electron that calcium has it's wanting to get rid of. Like that. On the other side, we have one calcium ion, and since it got rid of 2 electrons, its charge became more positive. Because we lost a negative, charge becomes more positive by 2. So we have calcium 2+, or you could say +2, it doesn't matter. And then we have 2 bromines, so Br. Both of them have 8 valence electrons now. And they also both have a -1 charge. I put that in the wrong place, so the drawing is correct, but the place it was placed is not right. So let's hit Control X. I'm going to cut that and put it where I meant to put it, which is right here, and expand the drawing out. So learn from my mistake and make sure that you have clicked in the right box before you start your drawing. It's not too bad, but it would have made my life a little easier if I hadn't done that. Okay, over here we're going to write out our symbol based on how many of each type of ion we have. So we have one calcium ion, has a +2 charge, but we only have one of them. But we have 2 bromines. So the way we show that is we put Br, and to show that we have 2 of them, we hit Control, comma, or you can go to New Equation, and over here there's a subscript that you can click on. So CaBr2, that 2 shows that there are 2 bromines. Just in case you can't get that to work, let me show you how to do this with the equation tool. Click on New Equation, and then right here you've got the subscript. So I would put CaBr, and then push the over button, and then 2.